Alrighty, so in this video we're going to go over problem number 6 from page number 7 of exam number 3 in relation to logarithms and the L'Hopital's rule. So in this case, where you asked to evaluate the expression of the limit expression of x to the limit of x approaching to 0 from the positive side of x plus 1 to the power of 1 over x. So in this case, we're asked to combine logarithmic and the L'Hopital's rule in order to finally evaluate this problem to a t. So what do we want to do first? So using L'Hopital's concepts, we want to first determine if this is a non-determinate form or indeterminate form for the limit. So in this case, we want to plug in this 0 into the function in order to determine that. So in this case, what we want to do is we'd have 0 plus 1 to the power of 1 over 0, which in this case would just be 1 to the power of infinity. So this right here represents the indeterminate form, one of the many indeterminate forms. However, this indeterminate form does not help us apply L'Hopital's rule directly, in which we can find the derivative of this, because it does not end in either the infinity over infinity or the 0 over 0. So in this case, what we want to do is we want to write this expression in terms of y. So we want to do y equals x plus 1 to the power of 1 over x. And then since we have a function as an exponent, we want to use natural log in order to bring this down and therefore help us solve this. So in this case, we take the ln of y equals ln of x plus 1 over 1 to the power of x, which in this case, it would just equal to ln of y equals 1 to 1 over x times ln of x plus 1. So now that we have this expression rewritten in terms of natural logs, we can now rewrite this in terms of the limit. So we want to apply the limit to both sides of the equation. So in this case, we want to do limit of x approaching to 0 positive equals limit of x approaching to 0 positive as well of 1 over x. Oops, sorry, I forgot to write the ln. So we want to do the limit of x approaching to 0 positive of ln of y equals limit of x approaching to 0 positive of 1 over x times ln of x plus 1. So in this case, what we can do is we can apply the limit value inside of the function or to see if this is non-determinate form or not. So in this case, we have 1 over 0 times ln of 0 plus 1, which in this case would have infinity times 0, because ln of 1 is just 0, and then 1 over 0 just equals to infinity. And it would be positive infinity because 0 is positive in this case. So this, once again, is not one of the main indeterminate forms that enables us to apply L'Hopital's rule directly into the function. So what we have to do now is we have to rewrite this in order to help us find one of these and to apply L'Hopital's rule directly. So in this case, what we can do is we can rewrite this as limit of x approaching to 0 positive of ln of y equals limit of x approaching to 0 positive of, we can combine these two together. So in this case, combining these two, because we have multiplication, we have two terms here that are being multiplied together. So we can just say ln of x plus 1 over x in this case. So now, since we have this, we want to apply the limit value into the new expression. So in this case, we have ln of 0 plus 1 over 0. So that should just be 0 over 0. So now we have one of the main indeterminate forms that helps us apply L'Hopital's rule directly into the function. So we can now find the derivative of both the numerator and the denominator. So in this case, we can rewrite this as limit of x approaching to 0 positive, ln of y, and then we want to apply L'Hopital's rule, so we write the LH and then over the equal sign, and then that equals the limit of x approaching to 0 positive, and then now we want to find the derivative of both sides of the fraction individually, so that the derivative of the numerator in this case would just be 1 over x plus 1, but since the inside derivative is just 1, we can just leave it as this because this times 1 is just this. So this over x, so the derivative of x is just 1 in this case. So this is the new expression that we have. But we can rewrite this as simply just we can just apply copy dot flip. So we copy this, x plus 1 times 1 over 1, which this case just equals 1 over x plus 1. So in this case, we can just rewrite this as limit of x approaching to 0 positive, ln of y equals limit of x approaching to 0 positive of 1 over x plus 1 in this case. So this is what we have for our simplified expression. So in this case, now we can just apply the derivative, or sorry, the limit function, the limit value into this expression. So now we have 1 over 0 plus 1, which is just 1 over 1, which just gives you 1 in this case. So now we can say that limit of x approaching to 0 positive, ln of y equals 1. But we cannot just leave it like this because we still have the ln over here. We want to try to get rid of that so you can just have y equals, because we set the initial expression as y equals. So in this case, what we can do is we can use the Euler's number in order to get rid of ln. So in this case, we can just rewrite this as limit x approaching to 0 positive of e, so ln of y equals e to the power 1, which in this case, we just get these two cancel, so you just get limit of x approaching to 0 positive, y equals e to the power 1 is just e in this case. So now that we found this, we can safely say that the limit of the initial expression, which is just limit approaching, limit as x approaches 0 from the positive side of x plus 1 to the power 1 over x, just simply equals e. So this should be the final answer for this problem. Thank you.